Hi everyone, welcome back to another video. Today we're going to go over 3.3 Trigonometry internal assessment for calculus, and I'm going to walk over a past paper and sort of break it down into two videos. So this first video we're going to be doing the first task, which is usually achieved or merit, and in the next video we're going to have a look at the excellence part, which is a little bit more complicated. So have a read of this context and I'm going to get straight into the assessment. So the first task is we need to identify mathematical models for the position of each horse. So that's basically just telling us to find the equations that model their movement. You have to have a read through and pick out the important parts. So I've already highlighted some stuff here. So we've got two people, Susan and Evelyn, and they are on different sections of the ride. So Susan is on the inner ring and starts with her horse going upwards, so that's important. Her horse reaches a maximum height of 2.5 meters after 1 minute. Okay, so that's the x coordinate and the y coordinate, and then continues to reach this maximum every 3 minutes. So we know the period is 3. Her lowest position is 0.7 meters above the floor. Cool. So, and then this is for Evelyn, but we're going to start with Susan first. Don't know why I've got a pi symbol there. Susan, mathematical. And I'm actually going to do everything, like I'm going to type out everything. So just to take a break from handwriting notes. So it's usually in the form of y equals a sine b x plus c plus d, right? So remember, a is the amplitude, b is found by doing 2 pi. Oh, that's why I had that pi sign. 2 pi over the period. C is the horizontal shift, which is found when you plug in a y coordinate for either the maximum or minimum and when that happens with the x value. And then D is the vertical shift, right? So we're going to start with finding D. To find D, it's always the max plus the minimum divided by 2. I'm actually going to bracket all that to make it more clear. Divided by 2. So that's going to be the maximum. If we're only focusing, let's just not worry about this one now. I'm just going to highlight it red so you don't focus on that because that's a different person. Maximum height of 2.5. So the max is 2.5. And the minimum is 0.7, right? And all of that is divided by 2. So brackets, because we're dividing the whole thing by 2. So that's going to be 3.2 divided by 2 is 1.6, right? So there's my D value right there. Now the amplitude is always the max minus the D value. So that's going to equal 2.5 minus 1.6. And that's going to equal 0.9. Okay? And that checks out because from 0.7 plus 0.9 gives us our 1.6. And then from our 1.6 plus 0.9, that also gives us our maximum of 2.5. So that checks out. So we're going to find the B value now. So we know that the period equals 2 pi divided by B. If we rearrange that, we're going to get B equals 2 pi divided by the period. Now, it says it reaches a maximum height of 2.5 meters after 1 minute and then continues to reach this maximum. So a maximum to a maximum is the period. A maximum to a minimum is half the period. So if it was like a maximum to a minimum, whatever value that was, we need to multiply it by 2. But because it's a maximum to a maximum, makes things easier for us. So it's just going to be 2 pi. So B just equals 2 pi divided by 3. That's our B value. I'm actually going to see if I can get a symbol for pi. see if we can get a symbol for equation. Nah, that's is there pi anywhere? Nah, actually, oh goodness. No, we won't worry about that. Won't worry about that. Never mind. Okay, so we have got almost our full equation. We just need to work out some other stuff. So we've got our amplitude of 0.9, and it's sine 2 pi divided by 3 x plus c plus the 1.6. So now we just need to find this c value here, okay? And to do that, we need to plug in a value for y, and we need to plug in a value for x. So they told us that it reaches the maximum height after 1 minute. So that 1 minute is what we're going to plug in for x. So we're going to have 2.5, which was the maximum, equals 0.9 sine. Make sure you're going to copy and paste that whole thing. Boom. 1 plus c, right? That was the 1 minute here. So if we do some math, 2.5 minus 1.6 is 0.9 equals all this again, right? Delete the 1.6 because we minus the 1.6 off. So that's how we got the other side to 0.9. And then we divide now. 0.9 divided by 0.9 is 1. So I'm going to do that whole thing again. Equals that whole thing, but now it is divided by 0.9. And if you were now going to do the inverse of sine, so sine to the negative 1 of 1 is going to equal all this. Just that. Boom. So we do the inverse of sine, negative 1. And then if you put that into your calculator, right, I've got a graphics calculator here, you need to make sure you're in radians. So shift menu. I don't know how this bloody thing works. Wait, let's just see if it works. Sine 1. It should give me pi over 2. If it doesn't, it's in the wrong unit. There we go. That works. Perfect. So as you can see, pi over 2, or half of pi, equals all this here. Right? And that was just inverse sine. Now we can cancel out the pi's. So we're actually going to get 1 over 2 equals 2 over 3, 1 plus c. So that was eliminate the pi. So you just basically turn the pi into 1. Now, to get rid of that fraction, we can multiply by the reciprocal. So 1 half times 3 over 2, not 2 over 3, equals 1 plus c. So that was multiply by reciprocal. I don't know how to spell it, which is basically the fraction flipped upside down. So we do that in our calculator. We're going to have a half times 3 over 2. Is it going to type or what? 2? No. Oh, this calculator sucks, 2. 3/4. Perfect. So we've got 3/4 equals 1 plus c. So therefore, 3/4 minus 1 should be negative quarter. So shift answer minus 1, negative 1/4. So c equals negative 0.25. Right, we've found our equation now. Now we're just going to plug it all back in. So I'm just going to copy and paste this so I can do it quicker. Boom. And now we can, instead of the plus, it's going to be minus 0.25. And you can also have it in terms of not y and x to make it relate to the context more. So what does it ask? For the position of each horse. So you could write it as, because we found Susan. So let's do position S. So that S should be small, by the way. So just pretend that's small. And then instead of X, it's a time value. So it'll be T. There we go. So that's the first equation that models Susan's movement on the horse.